Okay, ladies and gentlemen, it is 4 o'clock Eastern on a Thursday, and these days, that means, of course, it's time for Hot Technologies. Yes, indeed, my name is Eric Cavanaugh. I will be your moderator for today's web seminar. And it's good stuff, folks. Big iron meet big data. I just love that headline. Liberating mainframe data with Hadoop and Spark. I want to talk about old meets new. Wow, we're covering the spectrum of everything we've talked about in the last 50 years of enterprise IT. Spark meets mainframe. I love it. There's a spot about yours truly and enough about me. So the year is hot. We talk about hot topics in this series because we're really trying to help folks understand certain disciplines, certain spaces. What does it mean to, for example, have an analytic platform? What does it mean to liberate big data from mainframes? What does all this stuff mean? We're trying to help you understand specific kinds of technologies, where they fit into the mix, and how you can make use of them. So we have 2 analysts today, and then, of course, Tendu Yogochu of ThinkSort. She is a visionary in our space. Very pleased to have her online today with our own Des Blanchfield and Dr. Robin Bloor. So I'll say just a couple quick words. One is that, folks, you play a big part in this process, so please don't be shy. Ask some good questions. We'd like to get to them during the Q&A component of the webcast, which is usually at the end of the show. And all I have to say is we've got a lot of good content, so I'm excited to hear what these boys have to say. And with that, I'm going to hand it over to Des Blanchfield. Des, the floor is yours. Take it away.
Thank you, Eric, and thank you, everyone, for attending today. So I get quite excited when I get a chance to talk about one of my favorite things in the world, mainframes. They don't get much love these days. My view is the mainframe was the original big data platform. Some would argue they were the only computer at the time, and that's a fair point to make, but for over 60 years now, they have really actually been the engine room of what big data has of late been popularized to be. And I'm going to take a little journey on why I believe that is the case. So we've seen a journey in the technology hardware stack in the context of mainframes shift from the image that you see on the screen now. This is an old FACOM mainframe, one of my favorites. We've moved ourselves through into the big iron phase of sort of the late 90s and the dot-com boom. This is the Sun Microsystems E10000. This thing was an absolute monster. It had 96 CPUs, originally 64, but it could be upgraded to 96 CPUs. Each CPU could run 1,024 threads. Each thread could be an application running at the same time. It was just monstrous, and it actually powered the dot-com boom. This is what all the big unicorns, as we call them now, were running, and not just the big enterprises, some of the big websites. And then we ended up with this common off-the-shelf commodity PC model. We just strapped lots of cheap machines together, and we created a cluster, and we approached the big iron challenge and what became big data, particularly in the form of the Hadoop project that stemmed out of the open source search engine Nutch. And we essentially recreated the mainframe and lots of little CPUs being glued together and being able to act like LPARs and in the form of running separate jobs or parts of jobs. And they were quite effective and in many ways cheaper if you start out smaller, but invariably many of these big clusters have gotten more expensive than a mainframe. My view on these things is that in the rush from the dot-com boom through to what became Web 2.0 and now chasing unicorns, we've forgotten that there's this platform still powering many of our biggest mission-critical systems out there. When we think about what's running on the mainframe platforms out there, it is very much the big data, particularly the data workhorse, but certainly big data. Traditional enterprise and government systems like banking and wealth management and insurance in particular, we all use every day. Airline booking and flight management systems, particularly flight management, where real-time is critical. Almost every state and federal government at some time has had a mainframe, and invariably many do still have them. Retail and manufacturing, some of the old software that's just been around and has never gone away, just continues to power manufacturing environments, and certainly retail at scale. Medical systems, defense systems, certainly defense systems. This last couple of weeks I've read many articles about the fact that some of the missile control systems are all still running on old mainframes that they're struggling to find parts for, so they're figuring out how to upgrade them to new mainframes. Transport and logistics systems, and these may not sound like the sexy topics, but these are the topics that we deal with on a daily basis across the lives. And some very, very large telecommunications environments are still run on mainframe platforms. So when you think about the types of data that are in there, they're all mission critical. They're really important platforms and platforms we take for granted every day and that in many ways make life possible. So who's still using a mainframe? And who are all these people that are holding onto these big platforms and holding all this data? Well, as I say here, I believe it's easy to be fooled by the media shift from big iron to racks of common off-the-shelf clusters or cheap PCs or x86 machines into thinking the mainframe died and went away. But the data says the mainframe never went away. In fact, it's here to stay. So the research I've put together here over the last couple of weeks has shown that 70% of enterprise, particularly large enterprise data, still actually resides on a mainframe of some form. 71% of Fortune 500 still run core business systems on mainframes somewhere. In fact, here in Australia, we have a number of organizations that have a data center in the middle of the city. It's an actual underground computer room, effectively, and there's a number of mainframes sitting still just running there, ticking away and happily doing their job. And very few people know that walking around the streets right under their feet in one particular part of the city, there's this huge data center filled with mainframes. 92 out of 100 of the banks around the world, the top 100 banks that is, still run banking systems on mainframes. 23 of the top 25 retail chains around the world use mainframes to still run their retail management systems and ERP and BI platforms. Interestingly enough, 10 out of the top 10 insurers still run their platforms on cloud, and so much so they're actually on mainframe, and they actually power their cloud services from mainframe. So if you're using a web interface or a mobile app, somewhere there's some middleware and interfaces that actually talk to something really heavy and big at the back end. I found over 225 state and local government agencies worldwide running on mainframe platforms still. I'm sure there's a lot of reasons for that. Maybe they don't have the budget to consider new iron, but that's a huge footprint of very large environments running on mainframe with some very critical data. And as I mentioned earlier, most nations still run their key defense systems on mainframe. I'm sure in many ways they're trying to get off there, but there you go. In 2015, IDC ran a survey, and 350 of the CIOs surveyed reported they still owned and managed big iron in the form of mainframes. And it struck me that it's likely that that's more than the number of large-scale Hadoop clusters currently running worldwide in production. That's an interesting little stat there. I'm going to go away and validate that. But it was a big number. 350 CIOs reported they had one or more mainframes still in production. Last year, 2015, IBM gave us a mighty Z13, the 13th iteration of their mainframe platform. The media went wild about this thing because they were astounded that IBM was still making mainframes. But when they lifted the hood and had a look at what was under this thing, they realized that it was actually on par with almost every modern platform that we'd gotten excited about in the form of big data and Hadoop, and certainly the clusters. This thing ran Spark and now Hadoop natively. You could run thousands and thousands of Linux machines on it, and it looked and felt like any other cluster. It was quite an astounding machine. And so a number of organizations took these things up. In fact, I did some data on just how many of these machines they were taking up. Now, I've had the view that the 3270 text terminal has been replaced by web browsers and mobile apps for some time, and there's plenty of data that supports that. I think now we're entering an era where we've realized that these mainframes are not going away, and there's a substantial amount of data on them. And so what we're doing now is we're simply adding, what I call off-the-shelf analytics tools. These are not custom-built apps. These are things that are, bespoke one-offs. These are things that you can quite literally just buy in a packaged box per se and plug into your mainframe and do some analytics. So as I said before, the mainframe's been around for over 60 years, in fact. When we think about how long that is, that's longer than most living IT professionals' careers actually span, and in fact, probably some of their lives even. In 2002, IBM sold 2,300 mainframes. In 2013, that grew to 2,700 mainframes. That's 2,000 700 sales of mainframes in 1 year in 2013. I couldn't get accurate data on 2015, but I imagine it's rapidly getting close to the 3,000 units sold a year in 2015, 2013. And I look forward to being able to confirm that. So with the release of the Z13, the 13th iteration of the mainframe platform, which I think cost them around about $1.2, $1.3 billion to develop from scratch, IBM, sorry, that is. Here's a machine that looks and feels just like any other cluster we have today, and natively runs Hadoop and Spark, and can certainly be connected to from other analytics and big data tools, or invariably be connected to one of your existing or new Hadoop clusters. So I have this view that including the mainframe platform in your big data strategy is a must. Obviously, if you have one, you've got a lot of data and you want to figure out how to get it up there. They've been let collect dust in many ways, mentally and emotionally, as far as the business world goes, but they're here to stay. Connectivity and interfaces for all of your analytics tools to mainframe hosted data should be a key part of your enterprise and particularly government big data plans. And invariably now, software is noticing them, taking a good long look at them and realizing what's inside these things, and connecting and allowing us to start to get a bit of insight and a bit of a feel for what's actually under the hood. And with that, I'm going to hand over to my dear colleague, Dr. Robin Bloor, and he'll add to that little journey. Robin, take it away.
Well, thank you. Okay. Well, since Dad has, I don't know, sung the song of the mainframe, I shall go into what I think is happening in terms of the old mainframe world and the new Hadoop world, which is really, I guess the big question here is, how do you manage all that data? And it's not my opinion that the mainframe is being challenged in respect of its big data capability. Its big data capability is extremely, as Des has pointed out, it's extremely capable. And in actual fact, you can put Hadoop clusters on there. Where it's being challenged is in terms of its ecosystem, and I'll kind of elaborate on that. Here's some mainframe positioning. It has a high entry cost, and what has actually happened in the past, I don't know, since the mid-90s when the popularity of the mainframe started to dip, it's tended to have lost its low end, those people that bought cheap mainframes, and it wasn't really particularly economic for those people, but higher up actually, in the mid-range and the high range of the mainframe, it still actually was, and demonstrably actually is, incredibly inexpensive computing. It has to be said, rescued by Linux, because that made it possible. Linux implemented on the mainframe made it possible, of course, to run all of the Linux applications. A lot of Linux applications went there before big data was even a word, or two words, I suppose. And it's actually a fairly excellent platform for private cloud. And because of that, of course, it can participate in hybrid cloud deployments. One of the problems is that mainframe skills are in short supply. The mainframe skills that exist are actually aging in the sense that people leave the industry for retirement year after year after year, and they're only just being replaced in terms of the number of people. So that's an issue, but it still is inexpensive computing. And the area where it's being challenged, of course, is this whole Hadoop thing. That's a picture of Doug Cutler with the original Hadoop elephant. The Hadoop ecosystem is, and it's going to remain, the dominant big data ecosystem. It offers better scale out than the mainframe can actually achieve, and it's lower cost as a data store by a long way. The Hadoop ecosystem is evolving. The best way to kind of think about this is once a particular hardware platform and the operating environment with it becomes dominant, then the ecosystem just comes alive. And that happened with the IBM mainframe, but later happened with the digital VAX, happened with Sun's servers, happened with Windows, happened with Linux. And what's happened is that Hadoop, which I always think of or like to think of as a kind of distributed environment for data, the ecosystem is evolving at an incredible rate. I mean, if you just mention the various impressive contributions that are open source, Spark, Flink, Kafka, Fresco, and then you add into that some of the databases, the NoSQL and SQL capabilities that are now sitting on Hadoop. Hadoop is the most active ecosystem that actually exists out there in, well, certainly in corporate computing. But if you want to treat it as a database, it's, it just doesn't bear any comparison at the moment to what I tend to think of as real databases, especially in the data warehouse space. And that explains to a certain extent the success of a number of the big NoSQL databases that don't run on Hadoop, like CouchDB and so on. As a data lake, it has a far richer ecosystem than any other platform, and it's not going to be displaced from that. Its ecosystem isn't just the open source ecosystem. There's now a dramatic number of software vendors that have products that are fundamentally built for Hadoop or have been ported to Hadoop. And they just created an ecosystem that there isn't anything that can compete with it in terms of its breadth. And that means really it's become the platform for big data innovation. But in my opinion, it's still immature, and we could have long discussions about what is and isn't, let's say, operationally mature with Hadoop. But I think most people that are looking at this particular area are well aware that Hadoop is decades behind the mainframe in terms of operational capability. The evolving data lake. The data lake is a platform by any definition, and if you think of there being a data layer in corporate computing now, it's very easy to think of it in terms of the fixed databases plus the data lake making up the data layer. Data lake applications are many and varied. I've got a diagram here that just goes through the various data wrangling things that needs to be done if you use Hadoop as a staging area or Hadoop and Spark as a staging area. And you've got, the whole thing, data lineage, data cleansing, metadata management, metadata discovery. It can be used for ETL itself, but often requires ETL to bring the data in. Master data management, business definitions of data, service management of what's happening in Hadoop, lifecycle management of data, and ETL out of the Hadoop. And also you've got direct analytics applications that can run on Hadoop. And that's why it's become very powerful, and where it's been implemented and implemented successfully, normally it has at least a collection of these kinds of applications running on top of it. And most of those applications, particularly the ones that I've been briefed about, they're just not available on the mainframe right now. But you could run them on the mainframe on a Hadoop cluster that was running in a partition of the mainframe. So the data lake is becoming, in my opinion, the natural staging area for fast database analytics and for BI. It becomes the place where you take in the data, whether it's corporate data or external data. Mess with it until it's, let's say, clean enough to use and well-structured to use, and then you pass it on, and all of this is still in its infancy. So the idea, in my opinion, of mainframe Hadoop coexistence, the first thing is that large companies are unlikely to abandon the mainframe. In fact, the indications that I've seen recently imply that there's a rising investment in the mainframe. But they're not going to ignore the Hadoop ecosystem either. I mean, I've seen figures of, 60% of large companies using Hadoop, even if a lot of them are actually just prototyping and experimenting. The conundrum then is, how do you make these two things coexist? Because they're going to need to share data. Data that is brought into the data lake may need to transfer to the mainframe. Data that's on the mainframe may need to go to the data lake or through the data lake in order to be joined to other data. And that's going to happen. And that means it requires a fast data transfer ETL capability. It's unlikely that workloads are going to be shared dynamically in, let's say, a mainframe environment or with something in a Hadoop environment. It's going to be data that's shared. And the majority of data is inevitably going to reside on Hadoop simply because it's the lowest cost platform for it. And the end-to-end analytical processing will probably reside there too. So, in summary, ultimately we need to think in terms of a corporate data layer, which for many companies will include a mainframe, and that data layer needs to be proactively managed. Otherwise, the two won't coexist well. I can pass the ball back to you, Eric.
Okay, and Do, I just made you the presenter, so take it away.
Thank you, Eric. Thank you for having me. Hi, everybody. I will be talking about the SyncSort experience with the customers in relation to how we see the data as an asset in the organizations is leveraged from mainframe to big data analytics platforms. And I hope that we will also have time at the end of the session to have questions from the audience, because that's really the most valuable part of these webcasts. So for people who do not know what SyncSort does, SyncSort is a software company. We have been around actually over 40 years, started on the mainframe side. And our products span from mainframe to UNIX to big data platforms, including Hadoop, Spark, Splunk, and both on-premise and in the cloud. Our focus always has been on data products, data processing, and data integration products. Our strategy with respect to big data and Hadoop has been really to become part of the ecosystem from day one. As a proprietary software vendor who has been really focused on data processing with very lightweight engine, we thought that there was a big opportunity to participate in Hadoop becoming a data processing platform and be part of this next generation data warehouse architecture for the organizations. We have been a contributor to the open source Apache projects since 2011, started with MapReduce, have been in the top 10 for Hadoop version 2, and participated actually in multiple projects, also including Spark packages. Some of our connectors are published in Spark packages. We leverage our very lightweight data processing engine, which is completely flat file-based metadata and fits very well with the distributed file systems like Hadoop distributed file system. And we leverage our heritage on the mainframe, our expertise with algorithms as we put out our big data products. And we partner very closely with the major vendors, major players here, including Hortonworks, Cloudera, MapR, Splunk, and Hortonworks. We recently announced that they will be reselling our product for ETL onboarding with Hadoop. With Dell and Cloudera, we have very close partnership. Dell is also reselling our ETL product for as part of their big data appliance. And with Splunk, actually, we publish mainframe telemetry and security data in Splunk dashboards. We have a close partnership. So what is in the mind of every C-level executive? It's really, how do I tap into my data assets? Everybody is talking about big data. Everybody is talking about Hadoop, Spark, the next compute platform that may help me create business agility and open up new transformative applications, new go-to-market opportunities. Every C-level executive is thinking like, what is my data strategy? What is my data initiative? And how do I make sure that I don't stay behind my competition and I still am in this market in the next 3 years? So we see this as we speak to our customers, as we speak to our global customer base, which is quite large, as you can imagine, since we have been around for a while. Now, as we speak with all of these organizations, we also see this in the technology stack, in the disruption that happened with Hadoop. It's really in order to satisfy this demand about data as an asset, leveraging all the data assets an organization have. And we have seen the enterprise data warehouse architecture evolve such that Hadoop now is the new centerpiece of the modern data architecture. And most of our customers, whether it's financial services, whether it's the insurance, the telco, or retail, the initiatives are usually either defined as Hadoop as a service or data as a service, because everybody is trying to make the data assets available for either their external clients or internal clients. And in some of the organizations, we see initiatives like almost a data marketplace for their clients. And one of the first steps achieving that is often starting with creating an enterprise data hub. And sometimes people will call it as a data lake. And creating this enterprise data hub actually is not as easy as it sounds, because it really requires accessing and collecting virtually any data in the enterprise. And that data is now from all of the new sources like mobile, sensors, and as well as legacy databases. And it is in batch mode, and it is in streaming mode. So it is, data integration has always been a challenge. However, with the number of variety of data sources and the different delivery styles, whether it's batch or streaming real-time, it is even more challenging now compared to 5 years ago, 10 years ago. We sometimes refer to it as it's not your father's ETL anymore. So where we talk about the different data assets, as enterprises are trying to make sense of the new data, the data they collect from the mobile devices, whether the sensors in a car manufacturer or it's the user data for a gaming company, mobile gaming company, they often need to reference the most critical data assets in the enterprise, which is customer information, for example. These most critical data assets often live on the mainframes. Correlating mainframe data with these emerging new sources, collected in the cloud, collected through mobile, collected on the manufacturing line of a Japanese car company or Internet of Things applications, have to make sense of this new data by referencing their legacy data sets. And those legacy data sets are often on the mainframe. And this is, if these companies are not able to do that, are not able to tap into the mainframe data, then there's a missed opportunity. Then the data as a service or leveraging all of the enterprise data is not really tapping into the most critical assets in the organization. There's also the telemetry and security data part, because pretty much all transactional data lives on the mainframes. Imagine you going to an ATM. I think one of the attendees sent a message to participants here for protecting their banking system. When you are swiping your card, that transactional data is pretty much globally on the mainframes. And securing and collecting the security data and telemetry data from mainframes and making those available through either Splunk dashboards or other Spark, SQL Spark analytics becomes more critical now than ever because of the way, the volume of the data and the variety of the data. Skill set is one of the biggest challenges because on one hand, you have a rapidly changing big data stack. You don't know which project is going to survive, which project is not going to survive. Should I hire Hive or Peak developers? Should I invest in MapReduce or Spark? Or the next thing, Flink, somebody said, should I be investing in one of these compute platforms? That's, on one hand, that keeping up with the rapidly changing ecosystem is a challenge. And on the other hand, you have these legacy data sources. The new skill sets do not really match, and you might have a issue because those resources might be actually retiring. So there's a big gap in terms of the skill sets of people who understand those legacy data sets and who are who understand the emerging technology stack. On the second challenge is the governance. When you are really accessing all enterprise data across platforms, we have customers who raise concerns that I don't want my data to land, I don't want my data to be copied in multiple places because I want to avoid multiple copies as much as possible. I want to have end-to-end access without landing it in middleware. And governing this data becomes a challenge. And the other piece is that as you are accessing data, the bottlenecks, if you are collecting most of your data in the cloud and accessing, referencing it, legacy data, the network bandwidth becomes an issue across the platform. So there are many challenges in terms of having this big data initiative and advanced analytics platforms and yet leveraging all of the enterprise data. So what SyncSort offers is really, we refer to it as simply the best, not because we are simply the best, but also our customers really refer to us simply the best at accessing and integrating mainframe data. We support all of the data formats from mainframe and make it available for the big data analytics, whether that's on Hadoop or Spark or the next compute platform, because our product really insulates the complexities of the compute platform. You are, as a developer, potentially developing on a laptop, focusing on the data pipeline and what are the data preparation steps that to make this data created for the analytics the next phase, and take that same application run in MapReduce or take that same application run in Spark. And we helped our customers doing that when Yarn became available and they had to move their applications from MapReduce version 1 to Yarn. We are helping them do the same with Apache Spark. Our product, new release 9, is running with Spark as well and ships with a dynamic optimization that will insulate these applications for future compute frameworks. So we have accessing mainframe data, whether it's vSAM file, whether it's DB2 on Z, or whether it's telemetry data like SMF records or log4j or syslogs that needs to be visualized through Splunk dashboards. And while doing that, because the organization can leverage the existing data engineer or ETL skill sets, the development time is significantly reduced. In fact, with Dell and Cloudera, there was an independent benchmark sponsored, and that benchmark focused on development time it takes if you are doing hand coding or using other tools versus SyncSort, and it was about 60–70% reduction in the development time. And bridging the skill sets gap across groups, across those data silos, and also those data silos has also kind of silos in terms of the people. Usually the big data team or the data ingest team or the team that's tasked to develop this data as a service architecture do not necessarily speak with the mainframe team. They want to minimize that interaction almost in many of the organizations. So by closing that gap, we have as well. And the most important part is really securing the entire process, because in the enterprise, when you are dealing with this kind of sensitive data, there are many requirements. In highly regulated industries like insurance and banking, our customers ask, they said, like, oh, you offer this mainframe data access, and that's great. Can you also offer me making these EBCDIC encoded record formats kept in its original format so I can satisfy my audit requirements? So we make Hadoop and Apache Spark understand mainframe data. You can keep the sensitive data in its original record format, do your processing, and leverage the distributed compute platform. And if you need to put that back, you can show the record is not changed and the record format is not changed. You can comply with the regulatory requirements. And most of the organizations, as they are creating the data hub or data lake, they are also trying to do this at a single click to be able to map metadata from hundreds of schemas in an Oracle database to Hive tables or ORC or Parquet files becomes necessary. So we ship tools and we provide tools to make this a one-step data access, auto-generating jobs for the data movement and auto-generating jobs to make the metadata mapping. So we talked about the connectivity part, the compliance, the governance, and the data processing. And our products are available both on-premise or in the cloud, which makes it really very simple, because the companies don't need to think about what's going to happen in the next year or two if I decide to go completely in public cloud versus hybrid environments where some of the clusters might be running on-premise or in the cloud. And our products are available both on Amazon Marketplace, on EC2, Elastic MapReduce, and also through Docker containers. So just to kind of wrap up, so we have enough time for Q&A. It's really about accessing, integrating, and complying with the data governance, yet making all of this simpler. And while making this simple, design once and deploy anywhere in a true sense, because of our open source contributions, our product runs natively in Hadoop data flow and natively with Spark, insulating the organizations from the rapidly changing ecosystem and providing a single data pipeline, a single interface, both for batch and streaming. And this also helps organizations sometimes to evaluate these frameworks, because you may want to actually create an application and just run on MapReduce versus Spark and see for yourself, yes, Spark has this promise and provides all of the advanced analytics and iterative algorithms work best, machine learning and predictive analytics applications work with Spark. Can I also have my streaming and batch workloads run on this compute framework? You can test different compute platforms even using our product. And the dynamic optimization, whether you are running on the standalone server, on your laptop, in Google Cloud versus Apache Spark, is really a big value proposition for our customers. And it was truly driven by the challenges that they had. I will just cover one of the case studies. This is a Guardian life insurance company. And Guardian's initiative was really to centralize their data assets and make it available for their clients, reduce the data preparation time. And they said that everybody talks about data preparation taking 80% of the overall data processing pipeline, and they said it was in fact taking about 75–80% for them, and they wanted to reduce that data preparation transformation time to market for analytics projects, create that agility as they add new data sources, and makes that centralized data assets available for all of their clients. Their solution, including SyncSort products, is right now, actually, they have a kind of Amazon marketplace, look-like data marketplace, supported by a data lake, which is basically Hadoop, and NoSQL database. And they use our products to bring all the data assets to the data lake, including DB2 on mainframe, including vSAN files on mainframe, and the database legacy data sources as well as new data sources. And as a result of that, they have centralized reusable data assets which are searchable, accessible, and available to their clients. And they are really able to add the new data sources and service their clients much faster and more efficient than before. And the analytics initiatives are even kind of progressing with more on the predictive side as well. So I will pause, and I hope this was useful. And if you have any questions for me or any of the related topics, please, you are welcome.
Sure, and Tendu, I'll just throw one in. I got a comment from an audience member just saying, I like this design, once deploy anywhere. Can you kind of dig into how that's true? I mean, what have you done to enable that kind of agility? And is there any tax? Like when we talk about virtualization, for example, there's always a bit of a tax on performance. Some people say 2%, 5%, 10%. What you've done in order to enable the design once deploy anywhere, how do you do it, and is there any tax associated with it in terms of performance?
Sure, thank you. No, because unlike some of the other vendors, we do not really generate Hive or Pig or some other code that is not native to our engine. This is where our open source contributions played a huge role, because we have been working with Hadoop vendors, Cloudera, Hortonworks, and MapR very closely, and due to our open source contributions, our engine, in fact, is running natively as part of the flow, as part of the Hadoop flow, as part of the Spark. What that translates also, we have this dynamic optimization. This was something that came as a result of our customers being challenged with the compute frameworks. As they were going into production with some of the applications, they came back and they said, I'm just stabilizing my Hadoop cluster and stabilizing on MapReduce Yarn version 2, MapReduce version 2. And people are talking that MapReduce is dead, Spark is the next thing, and some people are saying Flink will be the next thing. How am I going to cope with this? And those challenges really became so obvious to us. We invested in having this dynamic optimization we refer to as intelligent execution. So at runtime, when this data pipeline is submitted, based on the cluster, whether it's Spark, whether it's MapReduce, or a standalone server, a Linux standalone server, we decide how to run this job natively in our engine as part of that Hadoop or Spark data flow. So there is no overhead because everything is done through this dynamic optimization we have, and everything is also done because our engine is so natively integrated because of our open source contributions. Well, does that answer your question?
Yeah, no, that's good. That's good. And I want to throw one more question over there, and then Des, maybe we'll pull you in, and Robin as well. I just got a hilarious comment from one of our attendees. I'll read it because it really is quite pithy. He writes, it seems that in the history of things, H-O-T, get it like IoT, is that the more you try to, quote, simplify something that's really complex, more often than not, the simpler it appears to do things, the more hanging rope is supplied. Think database query explosion, multi-threading, et cetera. Can you kind of comment on this paradox that he's referencing, simplicity versus complexity, basically, and what's really going on underneath the covers?
Sure. I think that's a very valid point. When you are simplifying things and doing these optimizations in a way under the cover, somebody has to take that complexity of what needs to happen, right? If you are parallelizing something, or if you are deciding how to run a particular job with respect to the compute framework, obviously there's some part of the job that's being pushed, whether it's at the user end, manual coding, or it's at the engine optimization. So there is a part of that. By simplifying at the user experience, there's a benefit, a huge benefit in terms of being able to leverage skill sets that exist in the enterprise. And you can kind of mitigate that paradox, mitigate that challenge of, yeah, but I don't have control over everything that's happening under the cover, under the hood in that engine, by exposing things to the more advanced users if they want to have that kind of control, by also investing in some of the serviceability type of things, being able to offer more operational metadata, more operational data, as in the example that this attendee gave for SQL query, as well as with the engine running. I hope that answers.
Yeah, that sounds good. Des, take it away.
I'm really keen to get a bit more insight into your footprint in the open source contributions and the journey that you've taken from, your traditional long-running experience in mainframe and the proprietary world, and then the shift into contributing to open source, and how that took place. And the other thing I'm keen to understand is the view you're seeing that businesses, not just IT departments, but businesses are now taking with regard to data hubs or data lakes, as people are saying now, and whether they see this trend of just one single consolidated data lake, or whether we're seeing distributed data lakes and people are using tools to put them together.
Sure. For the first one, that was a very interesting journey. As a proprietary software company, one of the first ones after IBM. However, again, everything started with our evangelist customers looking at Hadoop. We had the data companies like Comscore. They were one of the first ones adopting Hadoop because they were collecting digital data across the globe and weren't able to keep 90 days of data unless they invested a $10 million data warehouse box in their environment. So they started looking at Hadoop. With that, we started also looking at Hadoop. And when we made a decision and acknowledged that Hadoop is really going to be the platform, the data platform of the future, we also came to the understanding that we won't be able to have a play in this, a successful play in this, unless we were part of the ecosystem. And we were working very closely with the Hadoop vendors, with Cloudera, Hortonworks, Mapr, etc. So we started really talking with them because partnership becomes very important to validate the value a vendor can bring and also make sure that we can jointly go to the enterprise and offer something more meaningful. It required a lot of relation building because we were not known to the Apache open source projects. And however, we had great support from these Hadoop vendors, I must say. So we started working together and looking at how we can bring value without even our proprietary software in the space. That was important. It's not just about putting some APIs that your product can run on. It's to be able to say that I will invest in this because I believe Hadoop is going to be a platform of the future. So by investing R&D sources, we wanted to make sure it matures and becomes enterprise ready. We can actually enable some of the use cases that were not available before our contributions. That will benefit the entire ecosystem, and we can develop those partnerships very closely. So it took quite a lot of time. We started contributing in 2011, and 2013, January 21st, I remember the date because that date our largest contribution was committed, which meant that we can now have our products generally available from that point on. So it took quite some time to develop those relations, show the value, partners, become design partners with the vendors and with the committers in the open source community. But it was a lot of fun. It was very rewarding as a company for us to be part of that ecosystem and developed great partnerships. So the second question about the Data Hub, Data Lake, I think when we see these data as a service implementations, in most of the cases, yes, it might be a cluster, physically a single or multiple clusters, but it's more conceptual than becoming that single place for all the data. Because in some organizations we see large cluster deployments on premise. However, they have also clusters on, for example, in public cloud, because some of the data that's collected from online transactions is really kept in the cloud. So it's being able to have a single data pipeline that you can actually leverage both of these and view them as a single data hub, single data lake becomes important. Not necessarily it's just a physical place, that having that data hub and data lake across clusters, across geographies, and maybe on-premise and cloud is going to be very critical, I think, especially moving forward. This year we started seeing more and more cloud deployments. It's amazing. The first half of the year, this year, so far we have seen a lot of cloud deployments.
Okay, cool. And Robin, do you have any questions? I know we just have a couple minutes left.
Okay, well, I can ask a number of questions. The first thing that occurred to me is that there's been a lot of excitement about Kafka, and I was interested in your opinion about Kafka and how you integrate with the way that people are using Kafka.
Sure. Yes, Kafka is becoming quite popular. Among our customers, we see that being kind of the data transport layer and used as a data as a bus, pretty much. For example, one of our customers actually was using kind of consuming data that's pushed into this Kafka among multiple like thousands of online users, and being able to classify that and push through, again, Kafka as a data bus to the different consumers of this data, classify some advanced users versus not so advanced users, and do something different moving forward in that data pipeline. How we integrate with Kafka is basically our product, DMX-H, becomes a reliable consumer, a highly efficient, reliable consumer for Kafka. We can read the data, and this is not any different than reading data from any other data source for us. We give users the ability to control the window, either in terms of the time requirement that they have or the number of messages that they might be kind of consuming from the Kafka bus. And then we can also do enrichment of that data as it's going through our product and push back into the Kafka. We have tested this. We have benchmarked it at the customer site, also certified by Confluent. We work closely with the Confluent guys, and it's a very high-performing and easy to use. Again, there the APIs change, but you don't have to worry because the product really treats that as just another data source, streaming data source. It's quite fun to work with our product and Kafka, actually.
Okay, I have another question, which is just it's kind of a general business question, but I've known SyncSalt for a long time, you know, and you were always had the reputation, well, and delivered extraordinarily fast software for ETL in the mainframe world. Is it the case that most of your business is now being transferred to Hadoop? I mean, is it the case that in one way or another you've kind of spread your business out quite dramatically from the mainframe world? Our
mainframe products are still running 50% of the mainframes globally. So we have a very strong mainframe product line in addition to what we are doing on the big data end and the Hadoop end. And we are still in most of the IT simplification or optimization projects because there's one end that you want to be able to tap into your mainframe data in the big data analytics platforms and leverage all of enterprise data. However, there are also very critical transactional workloads that still continues to run on the mainframe, and we offer those customers ways to really make those applications more efficient, run in the zip engine so they don't consume as much processing cycles and MIPS, make them cost effective. So we continue to invest in the mainframe products and actually play into this space where people go from mainframe big iron to big data, and expand the product line also across those platforms. So we don't necessarily shift the entire business to one side. We continue to have very successful business on both sides. And the acquisitions are a big focus for us as well. So as this data management and data processing space for the big data platforms evolve, we are also looking to make, committed to make quite a few complementary acquisitions.
Right, well, I guess I can't ask you what they are because you won't be allowed to tell me. There is another, I'm interested in whether you've seen many implementations of Hadoop or Spark actually on the mainframe, or whether that's a very rare thing.
We have not seen any. There is more question about that. I think Hadoop on mainframe did not make, how to say this nice, a lot of sense because of the kind of the cost structure. However, Spark on mainframe is quite meaningful, and Spark really is very good with machine learning and predictive analytics, and being able to have some of those applications with mainframe data really is, I think, quite meaningful. We haven't seen anybody doing that yet. However, it's really the use case driving these things. If your use case as a company is more bringing that mainframe data and integrating with the rest of the data sets in the big data platform, that's one story. It requires accessing the mainframe data from the big data analytics platform, because you are unlikely to bring your data sets from open systems and cloud back to mainframe. However, if you have some mainframe data that you want to just explore and do a little bit of data exploration, discovery, apply some advanced AI and advanced analytics, that Spark might be a good way to go and to run on the mainframe as well.
And here's one more question from the audience, actually two more. I'll give you a tag team questions, then we'll wrap up. One attendee is asking, is IBM integrating your open source contributions on its public cloud ecosystem, in other words, the BlueMix? And another attendee made a really good point, noting that ThinkSort is great for keeping Big Iron alive for those who already have it, but as companies forego new mainframes in favor of what he calls CE, cloud everything, that need will likely decline, but notes that you guys are really good at moving data by bypassing operating systems up to a gigabyte per second. Can you kind of talk about your core strength, as we mentioned, and whether or not IBM is integrating your stuff into BlueMix?
Yeah, with IBM, we are already partners with IBM, and we had discussions for their data cloud services offering the product. Our open source contributions are open to everybody who wants to leverage them. Some of the mainframe connectivity is also available in Spark packages, so not just IBM, anybody can leverage those. In the BlueMix, we haven't done anything specifically on that yet. And do you mind repeating the second question?
Yeah, the second question was about your core area of functionality over the years, which was really handling bottlenecks of ETL, and obviously that's something that you guys are still going to be doing as mainframes, well, theoretically fade away, although to Des's point, they're still kind of rocking and rolling out there. But the attendee just noted that ThinkSort is very good at moving data by bypassing operating systems at up to a gigabyte a second. Can you just kind of comment on that?
Yes, I mean, that's really overall resource efficiency have been our strength, and scalability and performance have been our strength. We are not compromising. Simplify has many meanings. We don't compromise from those. When people started talking about Hadoop in 2014, for example, many of the organizations were not really looking at performance initially, they were saying, oh, if something happens, I can add another couple of nodes and I'll be fine. Performance is not my requirement. When we were talking about having the best performance, because we were already running natively, we were not even having some of the initial hiccups that Hive had with multiple MapReduce jobs and overheads with starting them. People were telling us, oh, that's not my worries, don't worry about that at the moment. But when we came to 2015, that landscape has changed because some of our customers already exceeded the storage that they had in their production clusters. So it became very critical for them to see what SyncSort can offer if you are taking some data from a database or mainframe and writing into a Parquet format in the cluster, whether you land and stage and do another transformation or just do the in-flight transformation and landed target file format made a difference because you are saving from storage, you are saving from the network bandwidth, you are saving from the workload on the cluster because you are not running extra jobs. So those strengths that we play in terms of being very conscious, we feel the resource efficiency under our skin at SyncSort. That's how we describe it. It is critical for us. We don't take it granted. We never took it granted, so we will continue to be strong with that, whether it's in Apache Spark or the next compute framework. That will continue to be our focus. And in terms of the data movement piece and data access piece, definitely it's one of our strengths when we are accessing DB2 or vSAN data on the mainframes in the context of Hadoop or Spark.
Well, that's a great way to end the webcast, folks. Thank you so much for your time and attention. Thanks to you, Tendu and SyncSort, for coming into the briefing room, stepping into the round, as they say. A lot of great questions from the audience. It's an ever-moving environment out there, folks. We will archive this for Hot Tech, as we do with all of the others. You can find us at InsideAnalysis.com and at Techopedia.com. Usually goes up within about a day. And with that, we're going to bid you farewell, folks. Thank you so much. We'll talk to you soon. Take care.
Thank you.
Bye-bye.
Bye.